How are you, my students? Welcome to our lesson today. We are still in the topic differentiation. Differentiation is our topic. And in the previous lesson, we were looking at how to find the equations of tangents to a curve. Equations of tangents to a curve. When you are given the equation of a curve, for example, y is equal to 2x squared maybe plus 3x minus 1, and you want to find, and you have been given at a certain point, let's say at a point 1, -2, and you are told to find the equation of that tangent, we say the first thing is to get the gradient function. That's the first step, find the gradient function. After finding the gradient function, find the gradient at that point, the gradient at the point given. Once you find the gradient, now you can take your gradient, then you have the point, for example, in our case 1, -2, and then an imaginary point xy. Then from the formula m is equal to change in y all over change in x, you'll be able to find the equation of that line. And we have seen that the equation of the tangent is in the form y is equal to mx plus c, which is the equation of a straight line. So in this lesson, we look at equations of normals to a curve. Equations of normals to a curve. And the first thing that I want to explain is what we mean by the term normal, so that we can be able now to find the equation of the normals to a curve. If you consider this curve here, let's say that's the curve, and we have our point here, and we want to know what we mean by normal at a certain point. If we have our tangent, the point that is touching that point, this is our tangent. This is the tangent. At that point, we can call this point A. At point A, when we talk of a normal is a line passing through the given point and perpendicular to the tangent at that point. So when we talk of a normal, again, is a line passing through the given point, passing through the given point, and at right angle or perpendicular and at right angle to the tangent. It is at right angle to the tangent. So if this is our tangent, and we come and measure here, we have 90 degrees to the tangent, we have 90 degrees, then we'll say that this is the normal. So a normal is a line passing through the given point. This is the given point, and at right angle to the tangent. So in our lesson today, we want to know how do we find the equation of the normal to a curve. When we have been given the curve and we are told to find the equation of the normal. Just before we do examples, I'd like to remind you what you covered in the equations of a straight line. When we have a straight line here and we have another line which is perpendicular to the first one at the point, at this point, let me use the ruler so that I can explain something before we do the examples on how to find the equations of the normals to a curve. So when we have that, so we can say that this line, here we have two lines. We can call this line 1 and we have line 2. These two lines, line 1 and line 2, are perpendicular to each other. So they form an angle of 90 degrees. So if we have the gradient of line 1 as M1 and we have the gradient of line 2 as M2, we realize that in the equations of a straight line, the product of the gradient, should be equal to -1. That is for perpendicular lines. So the M1, when we have M1, we multiply by M2, it should be equal to -1. So we need to know that before we do the examples, because in our case here, we have line 1, which is the tangent, we have the normal perpendicular to the tangent, and therefore we should note that the gradient of the normal times the gradient of the tangent should be equal to -1 because they are perpendicular. So if you have the gradient of line 1 maybe to be 1/2, and you want to get the gradient of M2, you just need to come and say M1 times M2 is -1. And therefore, if M1 is 1/2, and you don't know the M2, multiply by M2 is equal to -1. Therefore, it means that M2 will be equal to -1 divided by 1/2. So we are going to have -1 times 2/1, that is -2. So the gradient of M2 when M1 is -1/2, for M2 is 2. And for sure, when you multiply -1/2 times 2, you'll get that the product M1 by M2 is equal to -1. So I'd like us to do examples on how to calculate or how to get the equations of normals to a curve. And we have seen that a normal is a straight line, is also a straight line passing through the given point at right angle to the tangent. So we can do these examples. We are going to do several examples here. So the first one, we are told find the equation. The question is find the equation of the normal. In this case, now we have the normal. Find the equation of the normal to the curve. We've been given the curve, which is y is equal to x cubed minus 2x minus 1 at the point 1, -2. Find the equation of the normal. Find the equation of the normal to the curve y is equal to x cubed minus 2x minus 1 at 1, -2. So in this again, we'll start by following the procedure that we are following when getting the equation for a tangent. So the first thing, because we want now to get the equation of the normal, and we have the curve. So the first thing, we need to get the gradient. So first we start with the gradient function. We get the gradient function. So that is dy dx. So the gradient function, so we need to differentiate. So we have 3 times the constant of x, which is 1. So we have 3x, 3 minus 1. Then minus, here we have 1. 1 times 2, we have 2. X raised to power 1 minus 1, then minus 0, because the derivative of a constant is 0. So we have this as 3x squared minus 1 minus 1 is 0. 1 minus 1 is 0, and therefore a number raised to power 0 is 1, so we have minus 2. So that is the gradient function. Then, after getting the gradient function, we need now to get the gradient. We need now to get the gradient at the point 1, -2. So here we have the x and the y. So we need to get the gradient at that point. So where we have x, we substitute with 1. So our gradient, which is dy dx will be equal to 3 multiplied by x squared. Our x is 1, then minus 2. So we have 1, 3 minus 2, we have 1. So our gradient is therefore equal to 1. That is now the gradient at that point, and that is the gradient of the tangent. So if we hand the curve, if we have our curve in this manner, let's say we have our curve this way, and we have now this as our point, and we have the tangent here. We have the gradient of this tangent. The gradient is equal to 1. So we also want now, because we want to get the equation of the normal, we also need to get the gradient of the normal. Our point is this. So we also need to get the gradient of the normal. So if we have our normal here, this is the normal making an angle of 90 here. We also need to get the gradient. We have the gradient of the tangent. We require now the gradient. We can call it M1. We require the gradient of the normal. And the point that we have here, the point is 1, -2. So we find first the gradient of the normal, and we know very well the gradient of the tangent multiplied by, which is M, multiplied by the gradient of the normal, which is M1, should be equal to -1. And therefore, the gradient of the tangent is 1. Multiplied by the gradient of the normal should be -1. So for us to get the gradient of the normal, we divide this by 1 by 1. And therefore, our M1 should be equal to -1. And therefore, the gradient of the normal, which we have said is M1, is equal to -1. So now we have the gradient of the normal, we have the point, and we can get another point, which is an imaginary point x, y. So we find now the gradient of the normal at this point, 1, -2, and we have the gradient of the normal as -1. So we simply come and write the gradient for the normal is -1. Then the point we have 1, -2, and the imaginary point x, y. So with this now we can find the equation of the normal to a curve. And therefore we have our gradient we know is given by change in y all over change in x. Our gradient is -1 and whole number always over 1. Change in y we have y minus -2, y minus -2 all over x minus 1, x minus 1. So this is -1 over 1 is equal to negative times negative, we have positive, so y plus 2 all over x minus 1. So we can close multiply. We have 1 into bracket y plus 2 multiplied by is equal to -1 multiplied by x minus 1. Then we open the bracket. So we have y plus 2 is equal to x times -1, negative x. -1 times -1, we have positive 1. And therefore, we have that y will therefore be equal to -x plus 1. We take 2 to the other side, we have -2. So our y will be -x, 1 minus 2, which is -1. And this is the equation of the normal. This is the equation of the normal. And as we have seen, the normal is a straight line. And therefore, we also expect the answer to be an equation of a straight line, which is of the general form y is equal to mx plus c. And we can see clearly that our gradient is -1. And our gradient here is -1. So this is the equation of the normal. So I repeat, how do we find the equation of a normal given the curve? The first thing, we get the gradient function. Now, when we are getting the gradient function, we want to get the gradient of the tangent. We want to get the gradient of this tangent, and the gradient, therefore, when we get the gradient function, we have been given the points, so we can substitute x with 1, so we get the gradient as 1. That is the gradient of the tangent. So if we had been asked to find the equation of the tangent, we'll come and use this gradient. But now we are told to find the equation of the normal. So we also need to get the gradient of the normal. And we know very well that the gradient of the tangent times the gradient of the normal is equal to -1 because they are perpendicular lines. They are perpendicular. They are perpendicular lines. And therefore, the gradient of the normal is -1. So we have the gradient of the normal, we have the point where it is passing through, and we have an imaginary point xy. We use it now to find the equation of the normal. We can do another example. Example 2. We are still in finding the equations of normals to a curve. Finding the equations of normals to a curve. So we are given, in this case, we are given the following. We are told number 2. What is the equation? What is the equation of the normal? What is the equation of the normal to the curve? What is the equation of the normal to the curve y is equal to x squared minus 1 at the point 2, 3. At the point 2, 3. That's the equation. What is the equation of the normal to the curve y is equal to x squared minus 1 at the point 2, 3. Again, in this, we start by getting the gradient function. That's the first thing, the gradient function. So our gradient function dy dx, we differentiate this. So we have 2 times the coefficient of x, which is 1. We have 2. Then x, the power minus 1. Then when we differentiate this constant, we have minus 0 because the derivative of a constant is 0. So we are going to have, therefore, this is 2x. 2 minus 1 is 1. And therefore, our derivative is 2x. Then we need to get now, we get the gradient. We get the gradient at the point which we are given as 2, 3. So we have the coordinate for x, that's y, x, y. So we have therefore our dy dx, which is now the gradient, will be equal to 2 multiplied by the value of x, which is 2. And therefore our gradient is 4. That is now the gradient of the tangent. That's the gradient of the tangent. So the gradient of the tangent in our curve, if this is our point and we have the tangent, the gradient here is equal to 4. And we want to find the equation of the normal. So if we have now our normal here, this way, we have the point here, which is 2, 3. We can take another imaginary point here, x, y, and we also require the gradient of the normal. And because they are perpendicular lines, that is the tangent and the normal, therefore the product of the gradient is -1. So we have m multiplied by m1 should be -1. Our m is 4, our m1 is in question is equal to -1, so we divide by 4 by 4. So the gradient of the normal is -1/4. That is the gradient of the normal. Now we can now use, we have the gradient, we have the point and the imaginary point. Now we use it to find the equation of this normal. So we simply come and note it. We have the following. We have the gradient, which is -1/4. We have the point 2, 3 and the imaginary point x, y. We know very well gradient is given by change in y all over change in x, and therefore our gradient is -1/4. Change in y, we have y minus 3 divided by x minus 2. Then we cross multiply. So we have 4 times y minus 3 is equal to negative 1. We multiply by x minus 2. So we open the brackets. So we have 4 times y, 4y minus 3 times 4, 12 is equal to negative 1 times x, which is negative x. Negative 2 times negative 1 is positive 2. So a 4y is equal to negative x plus 2. We take 12 to the other side, it becomes plus 12. So we have 4y is equal to negative x plus 14. So we can write it in the form, we can leave it at this, it is very correct, or we can move ahead and write it in the form y is equal to mx plus c. So we'll have 4y is equal to negative x plus 14. We divide by the coefficient of y, which is 4. We divide by 4. So we end up getting y is equal to negative 1 over 4x. Then plus, we can divide this by 2 by 2, 7 over 2, or which is 3.5. So we have 7 over 2. And this is now the equation of the normal. And we can see clearly from this, our gradient is negative a quarter, the gradient of the normal. So this will give us the equation of the normal. So we need first, we get the gradient of the tangent. Then we can use m1 times m2 should be equal to negative 1 for perpendicular lines. We get the gradient of the normal. Then we use the gradient and the points to get the equation. Lastly, the last example in equations of normals to a curve, we have the following. Determine number 3, determine the point on the curve. Determine the point on the curve. We have been given the curve y is equal to a half x squared plus 4, at which we determine the point at which the gradient is 8. That's the first thing. Then hence find the equation. Hence find the equation of the normal. Hence find the equation of the normal to the curve, at this point. So that is the question that we have been given. Again, is also a very simple question. We are told to determine the point on the curve y is equal to a half x squared plus 4, at which the gradient is 8. That should be the first thing. Then we are going to find the equation of the normal to the curve at that point that we'll get. So we have the equation of the curve y is equal to a half x squared plus 4. The point where the gradient is 8, and therefore we need the gradient function so that we can equate to 8. So the gradient function dy all over dx, this is our gradient, is equal to 2 times a half, which is the coefficient of x. We have, when we multiply by 2, we'll have 1. So we have 1x. Then we have 2 minus 1. Then the gradient function of a constant is 0. So we have this one as 1, that is x raised to power 1. 2 minus 1 is 1. So our x is the gradient function. And therefore, because we have been given the gradient, it's a very interesting question because we have been given now the gradient. So we know very well the gradient, which is dy dx, is equal to 8. And we have seen the gradient function dy dx is equal to x. And therefore it means we equate x to 8. And therefore our x is equal to 8. So that is the first point, because we want to get the coordinate now. Now we come and get the value of y when x is equal to 8, so that we can get that coordinate. So we have the curve y is equal to a half x squared plus 4. So we have a half. Our x is 8. So we have 8 squared plus 4. So we have a half. 8 squared is 8 times 8, which is 64. We multiply by 64. Then we add 4. So by 2, 1, by 2 we have 32. 32 plus 4 we have 36. So the point, the y will have 36, and therefore our coordinate will be x8, y36. Then we are told, therefore, hence find the equation of the normal to the curve at this point. And therefore in that, again, we have the gradient, and the gradient is the gradient of the curve at that point, meaning that it is the gradient of the tangent. So if we have our curve this way, and this is the point, therefore it means that the gradient of this curve, which is the gradient of the tangent, so if the point is here and we have the tangent here, it is simply, draw it. If we have the curve and we have a point here and we have this as our tangent, it means that the gradient m is what we have been given as 8. And we want now to get the gradient of the normal. We have the gradient, we want first to get the gradient of the normal, and we have already gotten the point. The point here is 836. 836. So we get first the gradient of the normal so that we can be able to find the equation of the normal to the curve at the point 836. So we know for perpendicular lines M1, when we multiply by the gradient of the tangent, which is 8, should give us -1. So we can divide this by 8 by 8. So the gradient of the normal is -1/8. So we have the gradient m, which is -1/8. We have the point 836, and we have an imaginary point x, y. We have x, y. So we come and say gradient is given by change in y all over change in x. Our gradient is -1/8. Change in y, we have y minus 36. Change in x, we have x minus 8. So we close multiply this. We are going to have 8 multiplied by y minus 36 is equal to -1 multiplied by x minus 8. So we are going to open the brackets. We have here 8y. Then we have 36. We multiply by 8. That is 288. We have minus 288 is equal to -x. Then negative and negative, +8. So we have 8y, therefore, is equal to -x plus 8. When we take 288 to the other side, we'll have plus 288. And therefore, it simply means that our 8y is equal to -x plus 288 plus 8, that is 296. So we can leave it at that, or we can write it whereby the coefficient of y is 1, whereby we just come and say 8y is equal to -x plus 296. We divide by 8 by 8 by 8. So we get that y is equal to -1/8x, then plus 296 divided by 8, that is equal to 37. And this is now the equation of the normal. This gives us the equation of the normal. We can see clearly that the gradient is negative 1/8, which is the same here, the gradient of the normal. So our equation y is equal to negative 1/8 x plus 37. And that's how we find the equation of the normals to a curve. Just to do a summary of what we have said in this lesson, when you want to find the equation of a normal, equation of a normal, the first thing is to get the gradient function. Depending with the equation that you are given, the gradient function. From the gradient function, you can now get the gradient at that point, the gradient at the point given, the gradient at the point. And this gradient at the point is the same as gradient of the tangent. But now we want to find the equation of the normal. So you move ahead and get the gradient of the normal at the point. The gradient of the normal at the point. Then after getting the gradient, now you can use the gradient. Then you have the points plus the imaginary point, and then calculate the equation. Because when you have the gradient, you have a point, maybe you have a point, an imaginary point xy, and you have a point, let's say 1, 2, you can use this now to get the equation of a normal. So ensure when you are calculating the equation of a normal, ensure that you have the gradient of the normal. You also have a point and an imaginary point. So depending with the equation, you just ensure that you have this, and then you'll be able to calculate the equation of the normal. I would like you to do the following questions. Question number 1. Given the curve y is equal to x cubed minus 3x minus 1, find the equation of the A, the tangent, B, normal at the point 1, negative 3. Question number 2. Find the equation of the tangent and the normal to the curve y is equal to x cubed minus 2x squared minus 1 when y is equal to negative 1. Finally, find the point on the curve y is equal to x squared minus 3x plus 7 at which the gradient is 5, and the equation of the tangent and the normal at this point. Ensure that you do those 3 questions so that during the next lesson we can look at what we refer to as the stationary points, that is in a curve, the stationary points. Thank you for being attentive. Let us meet next lesson.